This is the first example of our idea, and this mirrors direct solar radiation to the top of tower, where the radiation is converted into thermal energy to produce steam for a turbine. The efficiency of turbines is only a few tenths of percent, and the remaining 60 or 80% of the energy is thrown away, but that power plant does not throw away the heat, but directs it to these greenhouses for their space heating. It is obvious that sales of the heat to greenhouses provide additional money, which can radically reduce the cost of electricity from similar solar power plants. Unfortunately, the heat sales in the case of this Australian power plant reduce the cost of its electricity by only a few tenths of percent, but this video will describe two methods of connecting a greenhouse and a turbine, which reduce the cost of electricity several times. That is why the following two methods lead to the fact that our solar electricity becomes cheaper not only than electricity from thermal and nuclear power plants, but also cheaper than solar panels, especially in Europe, Canada, and the northern United States. We understand that this is not the only type of mirror systems, and now I am showing other types of mirror systems for generating electricity without any tower, and they can sell thermal energy to greenhouses too. In addition, my YouTube channel studies cheaper types of mirror systems that will suit us even more. One of my old videos described solar power plants consisting of a large number of mirrors which produce a lot of solar thermal energy to heat a large mass of soil through pipes. The heating of the mountain occurs during sunny summer to a temperature of approximately 300 degrees Celsius, and then this thermal energy is stored for several months so that we can use it to produce electricity during the non-solar winter. This outer layer of soil, several meters thick, serves as a thermal insulation, but it is obvious that some of the thermal energy will be lost due to heat leakage. That my old video showed the results of calculating the heat leakage for the case of an artificial mountain with a volume equal to 4 pyramids of Cheops and such dimensions. It was found that 7% of the thermal energy of the mountain will be lost through its bottom, and another 8% will be lost through the top and sides of the mountain. Many of you have already come up with the idea to place a large greenhouse here, and especially interesting is the location of greenhouses here on the southern slope of our mountain. We understand that such greenhouses will be heated by the heat leakage and other options which will be described later. Unfortunately, the surface area of our artificial mountain is not large, and therefore most greenhouses should be located not on the mountain but around our power plant, and they should be heated according to the second and third options. The second option for heating greenhouses occurs through these pipes on the periphery of our mountain, at a depth of several meters from its surface or several meters above this groundwater. The greenhouses are heated by warm water, which circulates between these pipes and greenhouse heating pipes. It is interesting that the heat extraction through these pipes reduces the temperature of the periphery of our mountain, and this phenomenon leads to a decrease in these heat leakages to the outside of our mountain, although it increases these heat flows. The third option for heating greenhouses was described at the beginning of the video for the case of this Australian power plant, when the warm water for similar pipes in greenhouses is heated by condensation of steam after turbines. The third option covers about 90% of the heating needs of greenhouses according to approximately this graph, where the maximum heating is during these winter months. But these autumn months and these spring months also require a small heating. This is the production of the electricity during 12 months of a year, and we understand that this part of the thermal energy is emitted into the atmosphere. It is obvious that this part of the heating needs of greenhouses is covered by the second option, that is, by the heat from the periphery of our artificial mountain. It is interesting that the production of our solar electricity during these summer months is slightly less than during these winter months. It is a radical advantage of solar panels which have such a winter dip, 7 times less in winter in Finland or 3 times less for southern Europe. In addition, solar panels do not produce electricity at night and almost none during cloudy days, while our turbine fully operates on the energy of our hot mountain. And now let's compare the cost of electricity. This is an example of the cost of our solar electricity, and this is an accounting of the sales of thermal energy to greenhouses at a price of 2 cents per kilowatt hour, which will be justified in a minute. This formula leads us to the cost of solar electricity at 5 cents per kilowatt hour, and it is cheaper than electricity from thermal and nuclear power plants. Of course, solar panels can produce cheaper electricity in sunny deserts, but solar panel electricity is noticeably more expensive in more northern countries, especially in northern Europe. This is the same example of our solar electricity, but without those heat sales to greenhouses, and we understand that those heat sales reduced this cost of our electricity by 2 times. But the end of this video will explain that our method can reduce the cost of electricity several times. Let's assume that we have built many mirrors whose energy is used to heat an artificial mountain, and all 100% of its thermal energy is spent not on the electricity production, but only on heating greenhouses from October to April. This is the cost of thermal energy for greenhouses, where this is accounting of the hot mountain, this is accounting of the mirror systems, and this is the rest of the equipment. Here we see that greenhouses must pay about 2 cents per kilowatt hour of heat, and it is noticeably cheaper than heat from various energy sources and several times cheaper than heating with natural gas, especially in Europe. So, we use this heat exchanger to transfer heat from our hot mountain to the heating water of greenhouses. But many of us have already realized that we can add this turbine, which will produce electricity together with this heat for greenhouses. We will decide to spend money on this turbine only if we comply with a similar formula that leads us to this cost of our electricity. This turbine will produce electricity according to this graph, and we see that our electricity is produced only around winter and is absent in summer. Such winter production is usually very good for power systems of northern regions, especially if a region has many heat pumps for space heating or many solar panels that create an excess of electricity in the summer but a shortage of electricity in the winter. You saw that my formulas used this cost of our solar heat at the output of mirror system receivers, but it is too small for these expensive systems. The fact is that they can provide heat that costs about 2 cents per kilowatt hour in a sunny desert, but it will be noticeably more expensive in more northern regions. Nevertheless, my YouTube channel studies various types of simple and very cheap mirror systems which are trying to achieve the cost of about half a cent per kilowatt hour of heat in a sunny desert, but it will be closer to 1 cent in the northern regions. We must also draw attention to the fact that the cost of our electricity is highly dependent on these parameters, especially on this price of selling our thermal energy to greenhouses. For example, we can easily calculate that if this price is 3 cents per kilowatt hour of heat, this cost of our solar electricity will decrease by 5 times compared to this case without the heat sales. In addition, these numbers depend on climate, and the best place seems to be the northern United States, because these numbers will be better than in Europe due to sunnier winters and a longer heating season. But on the other hand, Europe may be better off due to the higher price of selling our heat to greenhouses, thanks to the higher market price of natural gas and other energy sources.